Business Intelligence for All, and this PhD is funded by ANI. So we will begin with this overview in whole presentation. I will start with the introduction, state of the art, then generating algorithm for dashboard generation, results, perspective, and with publication and courses. So let's begin with the introduction. So I will little bit introduce about the project, that is the BI for people. So the objective of this project, or I can say the whole project, to develop an open source data analysis tool, which we can say a business intelligence tool. And this whole project is divided into 7 work packages with automatic data warehousing and many others. Out of them, work package 4 is my thesis, that is automatic generation of dashboard. Now let's begin some key concept about the data visualization. So here I would like try to explain the difference between the single visualization and the multi visualization. When there is only one visualization, like a bar chart or scatter plot, we call them a single visualization. When there is more than one visualization, like you can see scatter plot, bar chart, line chart, we call them as a multi view visualizations, or we can say dashboard. Now, there is important system to generate the particular visualization, like automatic or manual. There's two ways. When user interaction is quite high and user is intervening and they are getting some feedback while generation of dashboard, we call them manual. But the user engagement is very minimum, or there is no user engagement, we call that generation of visualization or dashboard as automatic generation. Now here we justify the problem why we are working on this particular thesis. What we are doing, as I explained, we are working on developing a tool which is dashboard generation by automation by using some algorithm. Why we are working on this? Because currently there is no tool which is exist already, either scientific or commercial, which solve the issue faces by the novices, like existing tool are all mostly commercial, and there are no freeware tools which can be easily used by the novices people. Now, where this particular tool will help to the common people, especially like for the data visualization, for the analysis of the data, or when they are able to make the analysis, they can also make the decisions for their business or whatever they want. Now, how we will approach for the development of this particular software, you can say tool. First, we have or we will try to make this whole system as automated by using some particular algorithm which can be involve minimum user intervention or the user feedback to make it more automatic. And we will also focus finding some suggestion mechanism which can help them to generate the particular dashboard quickly and fast. So here we make a classification of the users. So generally we have divided the users in 3 groups, or you can say categories. One is the expert. We consider them like a researcher, business analyst, or senior professors. Apart from them, they are very much familiar with the scientific tools as well as the commercial. Second is the learners, like students, bachelors or masters or recent graduate. They are mostly familiar with the commercial tools like Tableau or Power BI. But here the question is still for the novices who are not in the domain of the especially computer science or the technical, how they can make this analysis of the data. So that's why ADIs come into existence. So now switch to state of art. So basically to begin our research initially, we try to go through many papers or the resources we found on IEEE, Explore, Euroviz, and finally we find around 1032 records. Out of them we screened 156 and we excluded some of them, and finally we have make a full access or the readings of this paper around 68, and we consider the qualitative synthesis of the 50 papers. Out of these, divided into different categories like survey papers or ADAGS, automatic dashboard generation. And finally, we find 19 systems which support automatic or semi-automatic dashboard generation. So starting with the first category that I can see in survey papers, we have found around 15 papers, survey papers, which we have divided into three categories. One is the journal survey paper and containing the information about the dashboard. Second is the survey focused on specific features. Third is the survey at the bottom you can see which are related to the visualization, suggestion, or you can say recommendation. While doing this literature or writing the paper, or I can say analysis, we find some important dimensions which are commonly in all these 19 systems. First, we study how it is important to study some dimensions to make any automatic generation tool or the software. So we finally find four important steps. One is the work origin, second is the suggestion of visualization, then is the layout, and last one is the user point of view. When we make a detailed analysis of these four categories, we find the detailed dimensions like work origin should be content like name, year, and reference, and suggestion mechanism should be like consider visualization, suggestion method, utility function, and then layout, and also considering the user point of view, that is the user feedback, their interface evaluation, and the type of the license it involved, particular software tool. Now, this is the list of whole 19 systems that we have found and do the detailed analysis. As explained, we have analyzed all these 19 systems on the 8 different dimensions and justify about them why we have categorized that particular tool or software in particular dimension. Now, out of these 8 dimensions, one of the important dimensions we find that is the algorithm they have used for the data visualization suggestion. Out of these all 19 systems, we find there are only 5 or 6 different types of the suggestion mechanism, which probably all of them I follow. One is the statistical properties of the data set. Second is machine learning method. Third is the visualization query language. And there's some miscellaneous like direct matching, behavior based, or you can say some predefined template or some heuristic functions. These are the 19 tools which we try to identify or categorize them into the different categories, like system which have used the machine learning and standard data set insights, like a data sort or data which tag, and second which only use the ML, that is the deep eye multivision and Drago. Last is the ST, which means statistical properties of the dataset like Scalar, Explorer, Calliope. Later again, we also define these systems into like behavior based and template like exploration view system which have used the direct matching and visualization query language, that is the Voyager 2 and GenVisage. So now these are the scientific tools in that I explained. Now here are the few commercial tools like Power BI, Tableau, ClickSense, to whom we do a detailed study and include in our survey. Now, one of the important tasks that during the survey we have identified is the system evaluation. We found that there are 7 systems which have performed the evaluation. For the objective was to do the system testing or the like features they have developed. 4 systems have performed the study or the evaluation for the competitive study, like in case of the Viztech, they have compared how their system is better than some other system. In same in the case of the Calliope, have performed a comparative study with the data sort. And next is a one system is that is the DeepI. They make a evaluation based on the machine learning, so there is no user involvement. And the 5 system are commercial, so there is no evaluation was available for them. 3 systems do not perform any kind of the evaluation like Drago, Datasort, and Sky Explorer. Next is the survey highlights. So these are the few survey highlights that we have found, like why we need our automatic dashboard generation recommendation system. Review of this survey that we have covered all the system which have the semi-automatic or the fully automated. Detailed study of each of dimension, as I explained, there are all 8 dimensions. presentation of our perspective and important guideline for design and development of automatic dashboard generation, and challenges and limitation we have highlighted at the end. And then which one of the important part, some limitation that we found which faces by the novices especially. So there is a more involvement of the technical keyword like dimension measures. Expert and researchers are quite fine with the commercial, but it's still a problem for the novices. The privacy concern, because for this software you have to upload data over there. Some visualization of the system are very complex, like map, tree map, or like scatter plot, which is quite difficult for them to understand, or area chart, you can say. Some the users don't understand this complex visualization. The interpretation of the data visualization will be very difficult for novices, and they will not able to make the decision. And some of these software are very costly and not affordable by the common people. Now let's switch to the third part of the whole presentation, that is the genetic algorithm for dashboard generation. So here is the whole system overview, how the whole model is working. I can say a kind of the workflow. First, user will upload the data, which is already pre-processed. And then there is a data model. We are extracting some information, like we can say metadata, where we have some different categories that we will see in this slide. After that, we have a visualization model to match particular data we identify from in the metadata. With the help of that, we make a visualization model to find which visualization is suitable for that particular metadata of the data set. Next, I have also task model, where we identify what particular task do user want to do. And after collectively all these things, we also have the model, user model, where we have some user inputs taking over here. So all these four collectively make an automatic dashboard generation system to determine optimal dashboard layout for the dashboard and presenting that particular dashboard in terms of the user interface, so that user can interact and user can see and make some inputs. For that, we have to consider the user feedback to add or remove the visualization that we will see later. So before moving forward, it's very important to explain a quick overview of the genetic algorithm, how we are implementing that for generation of dashboard. So the genetic algorithm, first we are generating a random generator that we consider as a dashboard with a combination of some visualization like bar chart, scatter plot. After that, we perform that we call it the population, and from this population, what the random generated as randomly like 1 to n. We select randomly any two pairs of the dashboard, or you can say individuals, like individual A and B will be one pair, C and D will be second pair. We perform a binary tournament among them, and one of them will be selected, each of them pair. So we selected the A and D from the pair 2. We perform a crossover among the both the dashboard individuals. Then after crossover, we got the two offsprings. One is 1, second is the 2. We randomly selected both out of these two, any one, let's say offspring 1, and we perform a mutation. Mutation can be performed here in add, remove, or mapping way that we will see in next slide. Finally, we evaluate here with whether that particular muted individual is better than the worst individual which is already present in the population. If the mutated on the evaluation of this particular is true, means muted evaluation fitness is better than the worst, then the replacement will be executed. Otherwise, GA will be run again and this process will be continued. So to better understand how we are doing, how genetic representation of dashboard is working, so just we have considered one of our worst dashboard here out of one of the population. So you can see here the scatter plot have the value a visual attribute map with the data attribute visited resources. Let's see scatter plot here. You can see on the x-axis is the visited resources, but on the y-axis we have the announcement view. Here you can see on the class is we can say categorical or you can say nominal. Here high, low and medium. So this is how we perform the mapping for the bar chart as well as the pie chart. So these are the some operators we have to discuss, like dashboard, visualization, data attribute and visual attribute in the whole GA. And the operations we have performed is the selection, mutation, crossover and replacement. Now let's see in detail how we have performed a selection and crossover. As I explained, we have selected the parent A and parent D after each of them after binary tournament. Then here maybe and the maximum number of the visualization in the dashboard can be 9 for the moment we consider. So we have randomly selected the cutting point. If it is selected cutting point over there 1, then we cut it over here and we perform a crossover. Like first part of the first parent will be joined with the second part of the second parent. So line chart, bar chart, the second part will be joined over here, and scatter plot of the first part will be joined offspring 1, and the remaining part I can say first part of the parent first second will be joined with the second part of the parent 1. So here we can see how the crossover is performed. Next is the mutation and replacement. So let's say the new dashboard is generated is the new dashboard 1, where we have make a mapping between the data attribute and visual attribute. So here you can see earlier it was the, let's see here, the scatter plot earlier was having here x and y a1, a2, a3. But here it got changed. The by come is matched with the A1 and X is matched with the A2 and there is no A3. Now it become matched with the A4. It is happening automatically. So this is how we are rearranging the mapping depending on the availability of that particular attribute. Next is the added visualization. Here earlier it was only 5. Now it's added only one more. But here between scatter plot and bar chart there is line chart, but we have removed over here. It means the remove of the visualization. So these are 3 ways we have performed mutation. And finally, we also do the replacement that the condition I explained is matched. Now we make some evaluation and test using some data set. So here we have a data set of students which have the 480 into 19 rows and column. We have conducted the 4 scenarios, out of them this 3. So in each of them scenario, we changes the value of the user importance. Like in here you can say gender, nationality and stage ID have only 50. While in the green you can say we make a higher importance. It means user is quite intensive to see or focused on these attributes. They must be in visualization or dashboard. We use that particular evaluation function with the formula negative complexity, positive coverage importance into match score. So this final score will give the fitness value. So the complexity, we define the ease of understanding the visualization. Like scatter plot is quite complex in comparison to histogram. So the value of scatter plot is quite more than histogram. Coverage importance is the attribute covered in a dashboard. If there in a dashboard there are 10 attributes, it will be high in comparison to a dashboard having a 3 attribute. The match score is defined with the help of the McKinley matrix, where we get the value or use the matrix to get the value from there. The matching of a visualization between the visual attribute and the visual and data attribute. After the result we can say the fitness function has a very fast to it takes very less time to compute. It is quite fast. We can say it takes 40,000 fitness evaluation was performed per second, and we make a run of the 20,000 generation with a 50 dashboard as a population. It was computed in a 6.4 second. So here we can see some results. So as I explained, they are the 4 scenario we have performed by changing their values, and they are the result of each of them. To study the GA parameters, we perform this grid search. On the top, we have a dashboard we consider for our initial population, and they are the generation that we have performed starting from 1K to 20,000. This is how initially in the syntax you can see over here, this is the average of best candidate of each generation during 10 runs, and in the bracket is the standard deviation of the same. So here is that we can say dashboard we have generated with the initial population. You can say one of the worst candidate I can consider it. So our algorithm was generated here. You can see total number of attribute. The coverage was 9. The primary attribute I can say which are important were only 5. Secondary was 1, and low importance like 10, which only 2. Now on the other hand, we will see here on the best after GA application of the GA, it is the 11, the total attribute. Primary are 6, all of them. Secondary are 3, and low are 2. Here is the better to see the comparisons. The initial population match score is almost similar, but coverage is quite, complexity is quite low for the initial. Complexity for after GA is quite less, and for initial is high, and the coverage is quite large for the after GA, but before is less, and this is the comparison. So let's move to the perspective. So here in future we have planned to do something like improve the fitness and the geo operators, and we will also work on taking consideration of the user feedback so that they can perform different types of the application or operations. We also take into account user behavior system like save, history, and concurrent workspace. We will perform a global optimization of the dashboard layout. We have planned to provide some predefined templates, so it will be very easier for novices. And at the end of the thesis, I will also perform a system evaluation by taking some users on live lab. So so I will move to my last slide. That is the publication and courses I have taken. So for the moment, we have only one publication in we have did in Clermont-Ferrand, which was presented, and but one of them was selected in Finland to be presented in July in IV conference 2023, which is on a genetic algorithm. And initially, we already submitted one paper in 2022, but this is under the first revision, or I can say second review, in a visual informatics journal. And I have taken around 4 to 6 courses in total, which include PhD and entrepreneur, which can have a credit 10. And overall, I can say I have completed around 55 credit out of 50 till now. So here I end my presentation. Thank you so much for listening.
Thank you very much, Praveen. So who would like to start? Maybe Bruno or Veronica, maybe it's up to you. I don't know. Maybe Bruno to have a real independent viewpoint.
So thank you very much, Pravi. I'm really impressed by what you did. That's so cool. I like everything I saw. Just when did you start your PhD? Can you remind me?
Yes, I began in 1st of October 2021.
So everything you just presented to us, you did this since last October?
Yeah, no, 2021.
2 years ago.
1 year, 1 year and a half.
Ah, you said 2022 or 2021?
2021.
Ah, 2021. Okay. Okay, I saw 2022 somewhere, but okay, never mind. No, that's great. You did cool science. You have publications, some accepted publications in a good venue or in good journals. And is your PhD 3 years long?
Yes, for the moment it will end like September 2024.
Okay. So you still have about 1 year. So at one moment or another, you will have to write your manuscript.
Yes, we have to also perform some evaluation, and we have to finalize the system because there are still many things that we have to take into consideration, as I explained. I have to take the user feedback into consideration. We have to improve the fitness as well as the GA much to do it much better, and we will perform some global optimization. And one of the important parts is to make a system evaluation.
I think that the question you have to take all these perspectives and to consider that you have also to write your manuscript.
Okay.
Yeah. Your perspectives are great. It's not surprising, but that's okay. But I'm not. I'm not sure we'll have the time to do everything you want.
Okay, okay.
It's always like that. A PhD is the end of the PhD is something like it's a depressing moment because you have to say stop. Okay, you have plenty of ideas. That is really cool for your defense, but do not underestimate the time to write a very good manuscript.
Okay, sure, I will take into consideration.
Veronica, maybe.
Okay. Yeah. Thank you, Bruno. Veronica, yes. Sorry.
It was very, very hard for me because there are a lot of things I didn't understand. I didn't get the point, but so I'm sorry. Most of my questions will be very silly. Very silly. Donc, first of all, you consider several types of users and you focalize in beginners. Beginners are somewhere between the experts and the children's, or are less expert than the children's.
So for beginner, we consider like
slide number 8. I think it was from the very beginning. Yeah, 8. Yeah, you have the
okay.
the
So maybe
expert,
it's
the children, and the novice.
So when we consider like children or whosoever, for beginner, it will be like I can say a graduate students. Like learners, like okay. Students or the masters, like maybe picture is not quite good. Okay, but I consider as students.
So they have some knowledge about the
yes.
things. Okay, and novices also at the very end.
Yes.
Yeah, okay. And so what is your goal? What is your real motivation here? I mean, you want to recommend one visualization, a set of visualization, a story? I mean,
yes.
in the tools you review, there are some of them produce a story, other ones will do one visualization at a time. So what is your ultimate goal?
Yes. So ultimate goal is first we consider that tools must be work well for the novice users. If people is not too much educated, they can also use. Second, in terms of the visualization, there should be a maximum, I can say between 2 to 9 visualization for the moment in a dashboard. So there is not only one visualization, it will be a kind of the dashboard or multi-visualization.
So you have some input data and you will provide a set between 2 and 9 visualizations.
Yes. So to answer it much better, maybe something like this, where it will be, we have a dashboard over here, which is come, user can interact like the other recommendations also, and make other interaction like changing the visualization, save the visualization, delete the visualization, something like this.
What is DVO?
Dashboard.
Dashboard.
We use this particular abbreviation.
Okay, dashboards. Okay. So you have several dimensions in the data, several dimensions at a time, and some visualization cross some of them.
Yes.
Okay, and you choose the thing. And what was the spirit, the idea behind applying genetic algorithms? I didn't get the point. I'm really sorry. I see there were a lot of work, but I didn't get the intuition, the motivation, so I was very, very lost. Ideas.
Before that.
Yeah.
Before that.
Yeah, I'm sorry, really sorry. I am useless here.
The question.
I recognized here the PhD supervisor. Thanks for reminding me the good old days.
Okay.
So can you explain again?
Yes, I am explaining. So basic idea about the GA we have tested, and finally we find that GA is working quite efficiently, especially in terms of the time. So user won't have to wait a lot for that particular generation of the dashboard.
Yeah.
And it is very effective. That's why we are using this.
What do you mix in? I mean, what are the things you are
okay,
in the genetic part?
So maybe you are asking about, first we try to identify different types of the models.
Can you go to the next slide? So you hear I or B, C or D. I don't get what are you're doing, crossing things and producing a mutation. I know the principle of genetic algorithm, but I don't know what is your tuple, what you are crossing and what you are.
What is a gene?
Okay. So basically, I try to explain in this slide. So here, different types of the operators, like we can consider a dashboard, whole dashboard as an individual. Visualization can be a gene. Data attribute can also a gene. Like here, you can say like gender, stage ID. We can consider them as a gene. Or visual attribute like X, by color, they can also a gene. But we can define a gene, small gene and big gene. Like when we are performing a mutation, there is a possibility add, and when we are adding any visualization or then in that case visualization will be a big gene. And when we are performing a mapping, we can say data attribute and visual attribute can be a small genes because the effect is not too much or too high.
So you have in the tuple, you have things that are of different the different kind, the different types, and then you mix them. Yeah.
Can you go before the slide before? No, just
This one?
This one, yeah. The table. The table on upstairs is a kind of a chromosome, so it's a dashboard. The 879, the 79 is a dashboard.
Okay.
And then we have where we have the different data that are showing the different the kind of the dashboard, something like that. All are a gene, and each gene and the different line compose the dashboard of the chromosome, and the genetic algorithm cross between the different lines. Do you understand?
Yeah. I have an idea. Okay, and then you cut in some way. But you cut horizontally, no?
No.
When you mix,
Yes,
you
we cut it horizontally. Like
yeah, you cut it horizontally, so you are mixing because each line is one visualization, and you have a set, so you are cutting horizontally. Okay, then you do a crossover, and this is quite okay. And then, how do you test that you are, the children you are obtaining here are better than parents? That is a very important property.
Okay. So for here, over here we are performing evaluation.
Yeah.
The evaluation key concept is a fitness value. Just suppose here are the 10 population. Okay, and randomly it have chosen the worst one, not randomly, the first one, which is I consider the worst fitness value. And
fitness with
when I say fitness value, I can this is the fitness value. The formula we have used for the fitness value is like multiplication of the coverage and match score, and then negative value of the complexity, because our objective is minimize the complexity, because if user want the bar chart or the histogram, it should be over there, and maximize the coverage means if user want all these 6 parameters in the green and yellow, they must be present in a dashboard what we are recommending, because this is the user importance is high.
These are chosen by the user or something like that?
Yeah, by the user, we can say.
Okay, there are some constraints that you measure the coverage of the constraints. Okay, a match is
like 100.
No, what coverage multiplied by match.
So you mean the match value?
Yeah, what is match?
Match value we have identified with the help of McKinley matrix. There is an author who have given the explanation how we can compute a value in particular order between a visual attribute and a data attribute. Like for visual attribute, it is the color, and having a numeric, then they have given the value 50. So there's a long table, we have followed that.
Okay, now I get. And how do you compare with the other works, the other tools that in your survey? Some of them provide stories, other ones
Yes.
provide, as Tableau
For-
provides several options, so you can consider that you have a set in some way. How is it? I mean, is it possible to compare, to have
Yes,
a baseline and compare
one-
your performance with respect to them?
It depends. That's be also presented in the limitation of the survey, that there is not any a single evaluation platform where you can give the input of all these systems by once and get the output like what we present in the GA. But on the user point of view or the user knowledge, we can do this. Like some person is testing them and they can give say, yes, this is the good tool and this is the bad tool, or comparative study what we did. But there is no automatic tool of the evaluation. But on the basis of that, we can say like data sort and the Calliope are the tools which are somewhere giving information in form of storytelling. Okay, like I can Skeg Exploit, one of the tool which is mostly focused on the optimizing a global dashboard. So where we get the inspiration, like dashboard is somewhere using a machine learning and behavior based the different types of the suggestion mechanism, and in addition to this, they have also given a visualization for a kind of the template. Oh, sorry, table. So on the basis of that, we have identified, like when you go on the layout, you will find there is only one tool out of all these 19 which have the optimized layout and optimized size.
Yeah, but I mean, there are a lot of tools. This is
Yes.
very nice for a survey, and then you make some links and saying, okay, these ones are very far from what I propose, and these ones are not very good, and so on. So you shortlisted some of them, and you are expecting to compare to them, or
Yes.
not at all. So which ones?
So we can say actually our survey is have focused on two dimensions. One, the system we have includes semi-automatic or automatic, which is also one of our objective. All these tools are either semi-automatic or automatic. Second, the involvement of the user is minimal, same thing, or there is no user involvement. So on the basis of these two dimensions, we have identified all the tools, and our objective is also same, that we are developing our tool for the novices where the involvement of the user is minimum, we can say.
Yeah.
And second, all these tools are the multi-visualization, means the dashboard. And we are also developing a dashboard. Even when you see my PhD thesis, it is the automatic generation of dashboard. So there's two words. One is the automation, second is dashboard. These are the two dimensions everyone are following. If we want to save, or the common thing in all the 19 system is only two, like semi-automatic or automatic, or multi-visualization.
So you shortlisted some of them?
Yes,
or-
all 19. Yes,
this is not
all,
a short list.
no, I mean,
Compared to all of them?
I mean on two dimension, that is automatic and semi-automatic, and second is I say
I think
it's not a comparison like a discussion. I think what Veronica asked is, do you think that you will compare with users, for instance, the different tool on each dimension? It will be complex and will be expensive in time time cost. So you have to choose in this list. Can you pick three, for instance?
Okay, which are most okay?
2 or 3 tools that for you
Yes, I got it.
remain meaningful for your study.
Okay, one I can say one of them is exploration view, that is at the fourth number. One of them I can say is data sort, which is also interesting and which is second last. And one is also I can say if I go for the scientific is the Voyager 2.
Voyager 2, data shot, and the first one was?
Data the exploration view at the fourth number from the top.
Okay, I don't know this one. Okay. So you are planning a user study or something like that, or you think it's not necessary? I mean, you are planning to propose your tool to real users to be test suggestions, and you are planning to compare, also providing the other tools and being
comparative
make a
study
comparison? Or
yes,
what,
we will plan to do like comparative study, but for the moment we don't plan to do this, but we'll focus on that. Okay. To compare our tool with them.
Do you have an idea of what exactly you will propose to these users?
Yes, like as you say, the exploration view is somewhere for they have focused for the novices. So we can compare the tool we have built is somewhere how it is better than exploration view, considering the user is novices. Second, like in data sort, somewhere they are presenting a whole dashboard in form of the story. Okay, but in our case, we are recommending the whole visualizations, multi-visualization form of the dashboard. So we can compare how we are different from how users benefited from storytelling or the way we are presenting. And Voyager 2, when you see the user interface of the Voyager 2, it have the many manipulation user feedback. User can give the feedback, like change the things. So we can also make a comparative study with our system, like I propose some user feedback.
Veronica, like, the question is, have you already built a map of what question we should ask to the users, something like that?
Or the type of testing. I mean, it's the kind of things that we do for the third year. Perhaps he didn't start thinking about this, or is already have an idea of what kind of things or what kind of action are being asked to the users.
Maybe he can do a complement of information about that, because he has an idea how to go through this way. Jill?
Yeah, I'm listening. Well, the problem for the evaluation is that some systems are not available, and that's a problem. But
yeah, I did last year with a Master 2 student comparative test of storytelling tools. He do a questionnaire. Actually, he generated for several topics, for several data sets. He generated stories with DataShot, Calliope, and there was another one that is not in the list. It's also a muse. It's coming. So he has three tools, generated studies, and has users have to see the studies and answer questions about this. What is the most coherent study? What is the visualizations that are more impacting, more nice, and there were a lot of questions. Of course, for you, it's not a study. Story is a set of visualization, but I think you can do this kind of things, generating, if you go for something that is fully automatic, generating a set of visualization with several tools, and ask the user what happens with one of them and the other, what are the good points of your tool or not, and these kinds of things. I will share with you the thing. Well, it's not the only kind of evaluation that can be seen, but these kinds of things takes time. This is why I ask, because you have to plan it, you have to go for many passes with the questions. Sometimes the questions are ambiguous. You have the barrier of the language that you have to test. If the question is not well expressed, then the answers are not exploitable. So it takes a lot of time. You have to start preparing it very, very early with respect to your calendar.
That was my initial question, in fact, that an evaluation takes time. Takes a lot of time.
Okay.
So you have to be careful because you have a PhD to terminate.
Okay, I will take into it.
So I pass.
Okay, I'm just writing this down too. All right. Well, I don't know if the PhD supervisors have questions, Fatma and Cyril. Personally, I don't have questions, Praveen, so we work together with Cyril and Fatma every week. So to me, it's okay, but my colleagues maybe have questions. I don't know. Fatma or Cyril?
No, I don't have any question.
Maybe I can make a complement of information. I think that Jill will and Praveen will work with a PhD, not a PhD, another graduate group of students for the user evaluation. That's is it still scheduled, Jill, or not?
Yes, it's possible. It's possible. Yes, but to perform a user evaluation and to give us the best chance of success, because unfortunately another problem with user evaluation is that you are not sure about the results. They can be negative with respect to your system. So we indeed have to include the user feedback, and we also have to provide a user interface. So that's some work to do. But I think that taking into account the user feedback, we have already started to list some use cases. Is a very important point. And it's a key point for success in such a system. So we have to implement this before, and maybe at the end of the year this will be done. And then we can work by the beginning of the year on the user evaluation. And we have to find also novice users. So I'm not sure that students in computer science are novice users from our point of view. So maybe just next to our building, we have the Faculty of Law. So maybe we can find some students over there. Maybe it would be interesting.
Yeah. What I can say, another component of information is Praveen has studied different fitness functions. He compared them. We made several tests before.
Yes, I think sorry, so we still have some work to do on the system. Definitely to study alternative genetic operators just to see if they are better or not, just to adjust the fitness function and even the graphs, the visualization. There are some small errors. You did not see them, but I saw them. But that we have to still work on. But those are minor adjustments before we do the user feedback.
So
and as you said, Bruno, also the perspective of Praveen are ambitious, and indeed maybe we won't have time to do everything. We have some ideas for the layout, but the layout is not the most important problem, because in other systems they use grids like we've done it, and grids are not too bad. Okay, indeed, if there was a time series, then it would be better to have a longer visualization than a square-like visualization. But the most important problem is the user feedback. That's why it is above in the list. So we concentrate first on the user feedback, and then if we have time, we will implement a layout algorithm. With Fatma, we've been working several times on, and myself also in the past 20 years ago, working on the layout of elements on web pages and stuff like this. So I have some ideas, but time might be missing to implement them. We will see that.
You already started the implementation, or
Of the layout?
yeah, of your system?
it's effective.
Yeah.
Yes.
Okay, so I think
Yes,
we
and
are.
it's in JavaScript, because for the project we had this technical constraint, so it's in JavaScript, so can be integrated in a web page. I would not say easily, but it should be possible.
Yeah, and I think that this PhD and other works we've done in the lab on the things as some point of correspondence. For instance, with data narration, from a part on multi-objective optimization, even if in this case we don't use multi-objective optimization, because we make an aggregative merging function. But yeah, we have several points of combination and things. We have a lot of, he has a lot of idea to develop. Everything cannot be developed. So we have to take it into consideration. But to go to the user evaluation, we have to improve first the system.
Yeah, especially because you are going with beginners.
Yeah.
Yes.
So it should be easy. Should be yeah. And we have to develop it.
Okay, that's fine for me. I'm sorry. Can you